Sorry, I just remembered to hit record. We're drawing the solutions through the 0.04. Just make sure you go all the way to the edges, and then I'll share my screen and show you what the scoring guideline says. So it's worth 1 point. So if you did that, give yourself a point. I mean, we're doing this one together, so you're going to get all the points. So here, I'll read it to you. It says it must pass through 0.4. I don't know how you'd mess that up. They highlighted that point for you. Extend at least to 4.5. Okay, so go all the way to the edges. Have no obvious conflicts with the given slope. I guess unless you no obvious conflicts, that's very subjective. I don't know honestly what that means. I guess as long as it's good enough. Do you remember how when you did these on Delta Math, if it was close enough, it counted it right? Only portions of the solution curve within the given slope field are considered. So if you do like a curly Q, don't do that. Like if you started doodling like a picture of your mother over here or something, they don't count that. Is all that I'm saying. Okay? It's only worth 1, so not a deal either way. All right, letter B. For 0 to 5 times 0 to 5, it can be shown that the graph is going to be above 1. Find the value 0 to 5 at which there is a critical point. All right, critical points. How do you get critical points? They come from what? What equals 0? So a slope means derivative. So we're going to set the derivative equal to 0. I'm going to do part B up here. So this is your derivative, dh dt. We're going to take this whole thing and set it equal to 0. I need to look back at the scoring guideline, but I'm betting that that's worth a point just for setting the derivative equal to 0. Like for understanding what the question was asking and knowing what a critical point is. Critical point means derivative equals 0. So 0 is a great number because it absorbs a lot of the problem. If you were to divide over this 1/2, it would still be 0. If you divide over this h minus 1, it would still be 0. So we're really just going to look at this portion, and we need to know our unit circle. I'll draw it for you. Cosine is the x part of the point. Where on your unit circle, up, down, left, right, is cosine equal to 0? Up, down, left, right is what I'm looking for. You want the x value, cosine is x, to be 0. Yeah, up and down. Let me think I think we only go up though, because aren't we given an interval? Yeah, 0 to 5. If you go like backwards or go the whole way around, you're going to get outside of the interval. All right, so up here, and how much rotation is that to get up to the top? Pi over 2. Up to the top is pi over 2. So you're going to have t over 2 equals pi over 2. That's our amount of rotation. And then what would you do to get t by itself? Or actually, basically, yeah, multiply by 2. The 2s are just going to cancel. So you get t equals pi, which is 3.14. Again, if you went further and went all the way down to this one, like our interval was 0 to 5. Pi is pretty much like right in the middle of that. If you went further, you're going to be outside of the interval. That is good to think about, though. All right, I think there was more to that question, though. We found that, but what else is it asking? Determine whether that critical point is the location of or corresponds to relative minimum, relative maximum, or neither, and then write a sentence. So before we even decide, your sentence is going to be, what is it, because usually we say f of x, but we would say h of t has say it was relative maximum at t equals pi because derivative changes from whatever to whatever there, or neither because there's not a change, All right, so we're going to take this derivative, this cosine t over 2, and we're going to go from 0 to 5, and we're going to put pi in the middle there. So let's think about on our unit circle from 0 to pi. And actually, if we plug pi in, it's going to end up being pi over 2. So we really want to just think about from 0 to pi over 2. Cosine is your x value. Is your x value positive or negative for this like section? Positive. The other way you can think about it, if you're like, hey, that bothered me. Do you know what the cosine graph looks like? It's a wave that starts at 1. So it starts like this. So that first section is above sea level, if you like that better. Few ways you can, or you can give it a guess. It's either positive or negative. All right, and then it's going to change there when you go to the other side, negative. So actually, it is a location of a relative maximum. Okay, so we're going to say h of t has, and I've drilled these sentences into you, a relative maximum at t equals pi because h prime changes from what to what? From positive to negative there. And again, I'll share my screen and show you the scoring guideline here. So this was worth 3, it looks like. Considers the sine of dh dt. You wrote t equals pi, you get a point. So for identifying that, and then your sentence at the end. And of course, they're going to write the most complicated way possible. They said for time 0 to pi, derivative is positive, and for pi to 5, derivative is negative. Therefore, pi is the location of. If they say pi is the relative maximum, they won't give it to you. Location of relative maximum. And then for C, differential equation, this is going to be on there, right? Everything with an H moves to the left, everything with a T moves to the right. So how would we move over this H minus 1? We'd divide. So it's going to be 1 over H minus 1 dH. Why did I leave the 1/2 there? Because we've talked about this a little bit. Because what's our goal at the end? To get H by itself. So the less stuff you move over to the left, the less stuff you're going to have to move over to the right at the end. All right, so equals 1/2 and then cosine t over 2. Actually, can I write that as 1/2 t? Is that all right? Sometimes that goes better. dt. What do you think about your antiderivative for the left side? ln, good. So ln h minus 1 equals, all right, you need an antiderivative for cosine. So a function that if you did the derivative, you would get cosine. It is sine. No, it's just sine. Now, there would be a u substitution, but if it's something simple, I always recommend you just think about your adjustment number. What adjustment number would you need for a 1/2? 2, and conveniently, the 2 and the 1/2 out front would simply cancel out, yeah, disappear. All right, so it's going to be sine 1/2 t, and then very important, we're going to put at the end plus c. Good job. Yes, so your adjustment number would be a 2. Remember if it was like 7x, you would have a 1/7 or whatever. This one's going to be a 2, but if you multiply a 2 out front, the 1/2 and the 2 are going to just cancel. Say this 1/2 wasn't there. It would have been this. But because the 1/2 is there, that goes away. Does that make sense? Okay. But if it's something simple, I don't want you to write out u equals this, du equals that. You know, it's a timed exam. All right, now what? We did our antiderivative. What's the next step? Yeah, we're going to plug in 0 for t. Sine of 0. Sine of 0, guys. I know, I wanted with confidence, though. Sine of 0. No, you were confident, though. 0. You were right. You just weren't confident. So that's why I kept, because nobody else knew. Let's try one more time. Sine of 0. 0. Look, if you draw sine, where does it start? 0. Sine of 0 is 0, which is good because all this gets wiped out and you just have c. I'm a little nervous, but we'll continue on. All right, and then what are we plugging in for h? 4. 4 minus 1 is 3. Absolute value of 3 is 3. There we go. You're going to go back to this step right here, recopy it literally exactly like it looks, except put plus ln 3 instead of c. And then what is your next step? Yes, solve for y. So to get rid of ln, good, perfect. You guys even use good vocabulary. So it's going to be h minus 1 equals. Now, you can write e to the power of blah, 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 blah. To shorten it a little bit though, E and ln are going to cancel. So it's just going to be 3e to the power sine of all of this. But if you were like, hey, I'm scared I'm going to mess it up, just put e to all of that. They have to give it to you. They can't mark it wrong. All right, and then we're nearly there. What's your last step? Yeah, +1. And I would do this. Write with pencil, not pen, so that you can erase some things. It's a timed test. It'll be faster if you can erase. This is always on there and it is worth a boatload of points. All right, let's see. How many is it? 5. Separating the variables is worth a point. Being one antiderivative and then a second antiderivative. So if you only got one of them right, you'd still get 2 out of the 5. All right. Getting that ln of 3 in there, like figuring out what the c value was, and then all the algebra or the calc, I guess, because we had to exponentiate of solving there. It will be on there. You will solve a differential equation and it will be worth a boatload of points. What I want to do for the next one, so it's not just me talking at you the whole time, I'm going to set the timer for 15 minutes. Because remember, it's 15 minutes per question on average. Okay. I'm going to have you guys try this one and then we'll go over it. You can score yourself. Okay, so you are given the graph of differentiable function f. It says that right here, graph of f from -6 to 7. You have a horizontal tangent at -2. So right here is where it kind of turns around. I don't think that actually comes into play. I'm not sure we need that. And is linear from 0 to 7. So all of this is a straight line, right? The region in the second quadrant that they have shaded there has a area of 12. So they give you this region R is 12. Let's just go ahead and find the others while we're at it, because I heard you guys talking about it. This is a triangle, 1/2 base times height. What'd you get for that area? 4, good. And then ending at 6 here, we have another triangle, 1/2 base times height. What did you get for that one? -1, good job. Below sea level. All right, so let's look at A. G is defined by this accumulation function. The accumulation does begin at 0. Remember, it doesn't always begin at 0, so just be careful. It begins wherever they tell you. It's like a because I said so kind of thing. Find all of these values. You don't actually need supporting work for these because you can do it without showing any work at all, but you do need to label them, and I'll show you the scoring guideline in a second, like I've been doing. All right, so for -6, that means you want to accumulate from 0 to -6. That's from here to here. So that would be what? -12, because you went backwards. All right, if you plug in 4, you want to accumulate from 0 to 4, which would be 4. And then if you accumulate from 0 to 6, 4 minus 1 is 3. It's a point for each of them. So if you got all of them, give yourself 3 points. Then look, here is the scoring guideline. It's just 1 point for each of them. But I went back and read this while you guys were working because I was curious about it. Supporting work is not required for any of these. However, any supporting work that is shown has to be correct. What we were talking about, even if your answer is right, if you wrote something that was incorrect before that, it's going to be wrong. So in that case, you would want to write as little as possible. Okay. Look at the next one, letter B. For the function g defined above, so we're still using this one right here, find all values from 0 to 6, so this portion, where there is a critical point. We just talked about this in the last problem. Critical point is where what equals what? Derivative equals 0. Now, when you do g prime, you're doing derivative of an integral. Remember, all you take is this x and plug it in. So what is g prime equal to? F of x. You have to link those together. All right, and we're setting that equal to 0. So on this interval 0 to 6, we're looking just at this part. Where does this graph equal 0? 4. So how does your sentence start? G of x has, and I am so sorry to tell you this, but if you wrote f of x has, you don't get the point because there's a different function that's f than g. So you got to be super, super careful. All right, g of x has a critical point at x equals 4 because, and then what's our reason? Yeah. They won't give you the graph either. Who's your source that you're citing? G prime. G prime. or f of x. Once you've linked them together, they're interchangeable. So instead of g prime, if you want to put f, that's fine. But I like when you cite the derivative because it is the first derivative test, right? Because g prime of x equals 0 there. I barely fit diagram. Here is your scoring guidelines. Did you guys get all that? Good job. Get a point for linking these together. So if you write g prime equals f, give yourself a point. And then for that sentence, you get another point. See if you can get both of them. So yeah, so you have to link those together to get the first point. You can't earn it retroactively. Sometimes if your final answer is correct, they'll give you the first point anyway, but not the case here. You have to link these together. Okay, but if you were good to this point, because I know C threw some of you off, how many points do you have if you nailed all of that? Oh. 5. 5 out of 9 is great. So even if you couldn't get part C at all, 5 out of 9 is fantastic. Okay. So let's look at C. Function H, so we have a new function now, is defined by this. And they love doing that, throwing a new function in like at the end of the problem. All right. Find the values of H of 6, blah, blah, blah. So let's do H of 6. We'll do them one at a time. If you plug in 6 here, and I am going to show the supporting work for this. Yes, because this is not like you can just look at a graph and say what the area is. You have to actually do stuff here. So I plugged in 6. Now you have an integral of a derivative. What happens to those? And instead of f prime, it is just f. So it is f of x such that negative 6 to 6, and we're going to do upper minus lower. This is fundamental theorem of calculus. So what is f of 6? Look at your graph. They even label it for you. That's why they do that. What is f of 6? Negative 1. And then f of negative 6, 0.5. Don't try to simplify that down. If you're having an off day and you say that that's positive a half, wrong. All right, what is the next thing they ask us for? Okay, so we're going to find h prime of x and then plug in 6. You have to do those things separately. If you link them together, it's a linkage error. So when we do the derivative of this, again, derivative of an integral cancels. All you're going to do is take that x and plug it in. So what is your derivative of this? F prime of x. Good. And so if you plug in 6, you're doing f prime of 6. You don't have the graph of f prime. You have the graph of f. Okay? So derivative means slope. You want the slope at 6. So right here at 6, what is the slope of this line? Welcome back to algebra 1. Down how much and over how much? Negative 1/2. Down 1 over 2. And then what's the last thing they asked us for there? Prime prime. All right, you're going to have to do prime prime of x and then separately plug in 6. If you link them together, it's a linkage error. So you have to do them separately. Right here, we said h prime equals f prime. So h prime prime equals f prime prime. Now, this is a little tricky, but I want to throw it out there. If you couldn't get it, now that I've explained it so far, if this is linear, the derivative is constant. And then if we do the derivative of it was constantly negative 1/2. And then if you do the derivative of a constant, that is 0. And then I think it was just a point for each of those answers. But let's see here. Oh, it's 4 points. Wait, hold on. Oh, that's because the first one had a little bit more to it. So uses fundamental theorem of calculus was a point, and then the answer. So if you got to this step, you got a point, and then the answer. This one was worth 2. So 1, 2, and then 3, 4. I'll share it again in case you're interested, but that's kind of all it says. I'm not going to read all of it to you because it's on the internet. You can find it if you want to. So for part A, for this one. They give you this equation, which actually isn't too terrible. And they give you dy dx. So they give you the equation and the derivative, which is great. So there's a point 2, 4 near an x coordinate of 3. Use the tangent line. All right, what two things do you need to write an equation of a tangent line? Point and slope. All right, the point they gave to us, 2, 4. Slope comes from derivative. So we're going to plug in 2 for x and 4 for y right there. So that will look like this. And you are actually within your rights to simply leave it like that. However, I am going to simplify this down because I don't feel like recopying all of that. That would be -4 over 19. Did anyone else get -4? Thank you. Okay, cool. And then you're going to put it all together. It'll be y minus 4 equals -4/19 x minus 2. And what is your last step to get your approximation? Plug in 3. So it'll be -4/19, 3 minus 2. Do you remember you have to plug in something that's near 2, like near the point of tangency? I don't actually think 3 is all that close to 2. I think it should have to be something like 2.1, but I digress. All right, and then what do you have to tack on at the end here? Yeah, +4. All right, go ahead. It can't be variables, it has to be numbers. But you could recopy this right here, but you have to, like, you could put this all right there instead of -4/19, but it has to be numbers. All right, let's see what I think this might have been worth 3. That's not the right problem. Oh, no, it's only 2. All right, so you get a point for getting the slope of the tangent line. So if you got that -4/19, you got a point. And then if you got all the way to the final answer, you got a point. I feel like there should have been a third point in between where you wrote the equation. If you got the -4/19, give yourself a point. If you got all the way to the end, give yourself a point. Did anyone get 2? Did anyone get all those? Deal. All right, I'm going to do part B next because I think that's the next easiest part. B and C are a little strange. All right, for positive times, no kidding, a particle is moving along another curve defined by this. So now we have a totally new equation. At the instant the particle is at the point 4, 2, that means x is 4, y is 2. The y coordinate is decreasing at a rate of 2 units per second. How will we label that? I feel like if I wait you out, someone will come up with it. Good. dy dt is -2. Good job. Why is it negative? Decrease. Perfect. I didn't even have to pull teeth there. That was awesome. All right. Now, what are they asking for? At that instant, what is the rate of change for x? So what's our question mark? Yeah, dx dt is our question mark. I don't know if it's going to be positive or negative, though, because this isn't like a cup filling up with water or leaking or something. I don't know what it's going to turn out to. So you know how I would usually put positive or negative, like what we're expecting? No idea. We're going to find out. All right, so we're going to do this derivative every variable respect to time, right? Derivative of y cubed. Good. 3y squared dy dt plus, careful with this, what rule do you need for this? It is a product rule. The first thing is 2x. The second thing is y. It's because you have 2 separate variables. So how does product rule start? First thing, all right, 2x. Derivative of the second, dy dt, plus the second thing, which is y, derivative of the first. So derivative of 2x is 2, yeah, perfect, nice job, equals not 24. The derivative of 24, which is 0. The common mistake is people will leave that as 24. All right, I realize that looks horrible, but we're just going to plug everything in. What was y? 2? I'm not going to narrate all of this to you. Just take the stuff and plug it in. And then we'll sift through it together. I just took all those numbers and plugged them in. It would be cool if some of them were different numbers than 2 or 4. You know what I'm saying? Like, throw a 7. I know, like, it looks like you're writing the same thing over and over again because you kind of are. But they do that on purpose to mess with you. All right, so again, you're within your rights to leave it alone, but I am going to simplify this down so it's not as messy. 2 squared, 4 times 3, 12 times -2. All right, so -24. And then this part, 2 times 4, 8 times -2, -16, plus 4 dx dt equals 0. All right, so -24, so I can't talk. -24 and -16, that would be -40. And then if you solve that, you would add over the 40 and divide by 4. And so what do you get for your final answer here? 10. Perfect. I think as far as related rates go, it's a gift. Related rates can be very, very hard. I think that one was not so bad. Let's look at the scoring guidelines. I think our timing is going to work out perfect for this class. All right, so let's see. It was worth 4 points. Implicit differentiation. So if you did x dt and dy dt, like if your format of that was correct, you got a point. If it is actually correct, you got a point. So it was 2 points for doing the derivative. Uses dy dt. Why is it a plus minus 2? Should just be -2. I think that's a typo. Plug things in, okay, is worth a point. And then your final answer is worth a point. So it was worth 4. So if you only got those 2 parts, how many points did you get? 6 out of 9 is awesome. So B and C kind of don't really matter that much. Now I'm going to go through them with you, but they are a little bit weird. All right. So letter B, is the horizontal line y equals 1 tangent to the curve? Here's visually what that would look like. Your curve would do something like that, and you would have a horizontal tangent line of y equals 1. I'm just drawing that so that you can understand what it would look like. Is everyone together with me here? That's visually what that would look like. That means this point is a what? Critical point. How do you get critical points? Derivative equals 0. You're going to take this whole thing and set it equal to 0. So if you had your wits about you enough to even get that far, I think, and we'll have to go back to the scoring guideline, but I think just doing that is worth a point. So sometimes if you can even just do the setup, you want to throw whatever you've got at these. If you sometimes even writing that will get you a point. Now, if you multiply over this 3 plus 4y, it's still going to be 0. So -2x equals 0. And so x equals 0. And what is y supposed to equal? 1. So what we're going to do to check and see if this is true or not, we're going to plug x equals 0 and y equals 1 back into this original equation and see if it gives us a true statement. See if it actually equals 48 or not. Does that make sense? Okay, because we want the y value to be 1. We found our critical point is at 0. So like if this is the point 0, 1, then yes. If it's not, then no. All right. So you're going to have to look at your paper because I can't fit this all on here. But we're going to plug 0 in for all the x's and 1 in for all the y's and see if that equals 48 or not. So does it? No. You don't need to work it out any further. It's a yes or a no. So you can be as wordy as you like. I'm going to show you how I wrote this. I would say no, y equals 1 is not a horizontal tangent line because critical point x equals 0 does not have y value of 1. The way they wrote it was a lot worse. I think that kind of gets the point across. I kind of wrote it in a way that made sense to me. A lot of what I do is interpreting the like AP language and turning it into basic English for you guys. I'll show you what they put. Let me go back up to part B. And it was only worth 2 points. But look, if you set this equal to 0, you got a point. All right, and then if you said no and gave some sort of logical reason, they gave you another point. But yeah, they kind of went through it the same way I did. 0, 1 is not on the curve. All right, last part here, C. All right, the curve intersects the positive x-axis at the point square root of 48, comma 0. Is that line tangent to the curve at this point vertical? To get a 0 slope, the numerator is 0. To get vertical, denominator 0. So what we're going to do is plug this in, square root of 48 for x, 0 for y, into our derivative and see if we get a 0 denominator. So it'd be -2 times square root of 48 over 3 plus 4, what was y? 0. Does that give you a 0 denominator? Yes or no is what we're looking at. No, I actually think this is really tricky as well, because if part B came out to a no, wouldn't you think part C would be a yes? No, but you have to remember that they're evil and it doesn't work that way. They both came out to a no. So we're going to say no. Here, how would you word it? What would you say? Like, you basically want to say why you said no. Yeah, I would say denominator of dy dx at, and you just need to mention that point, is not 0. And I believe that was only worth 1 point. So if you couldn't get it, it wasn't like a super huge deal. Let me just check really quick. I think it was only worth 1. Yeah, that was only worth 1 point. Just plugging that in and saying no was only worth 1 point. So the takeaway of this is, if you get to something that's super confusing, don't worry about it. It might not be worth that much. And if you answer everything that you can get, you're going to be fine.